Okay, today we're going to do factoring and solving polynomial equations part 2. Again, focusing on some factoring. Here are 4 problems. Hit pause, solve the 4 problems, come back, check your answers. Problem number 1. Common factor coming out of everything would be an x. This would be x squared minus 7x plus 10. See if you can factor further, which you can. This is x minus 5 and x plus 2. Problem number 2, anything common factor, 3y cubed. This leaves y squared minus 25. See if you can go further. 3y cubed, difference of squares, y plus 5 and y minus 5. Problem number 3, looks like difference of cubes. The a term, the first term is w, second term is 3. Our pattern, a minus b, a squared plus ab plus b squared. So this becomes w minus 3 times first term squared, two terms multiplied by each other, second term squared. Any common factors coming out of here? 2b squared. This leaves 8b cubed plus 343. This right here, sum of cubes. Here's our pattern, a plus b, a squared minus ab plus b squared. Our first term is 2b. Sorry for using the same variable. Our second term, b, is 7. So we bring this down, 2b squared. Then we do first term plus second term, a plus b. 2b plus 7 times first term squared. 2b squared is 4b squared minus first term times second term, 14b, plus second term squared, which is 49. Okay, our next factoring is factoring by grouping. This happens when you're going to have 4 terms and their descending order of exponents. I'm going to take this first group, see if there's any common factors. I can take out an x squared. If I take out an x squared, it gives me x minus 2. Any common factors out of here? I'm going to take out a negative 3. If I take out a negative 3, this is going to give me an x. That's going to give me a minus 2. That's why it's a negative 3. I need this parenthesis to be the same exact thing as this parenthesis here. Okay, you need them to be matching. Finish this up, we take the x squared minus 3, put that together, and then we multiply by a single x minus 2. If I FOIL this out, I'm going to end up back up at this original problem. Okay? Here's another 4 terms. We're going to try factoring by grouping. What do I have that I can take out of here? X squared. This would give me x minus 3. Now remember, I want this to be x minus 3. So what number can I divide positive 48 by to get negative 3? Negative 16. This is negative 16. That makes this negative 16. Put these together, x squared minus 16, and a single x minus 3. If I multiply these out, I would end up back at that original problem. Then what I want to do is I want to see if there's anything down here can be factored. Here's another special pattern. So we can go further with this problem. X plus 4 and x minus 4. Remember, you're not done until everything can be factored as far as it can go. So this is my final answer right down here. Okay, problem number 1. Hit pause, solve it on your own, come back and check your answer. Alright, glad you're back. Remember descending order of exponents. What can I take out of both of these? Looks like I can take a 9x squared out. $27x cubed divided by 9x squared is 3x. 45x squared divided by 9x squared is plus 5. Remember, I want this next group, if this is going to work, I need this to be a positive 5. So what can I divide negative 5 by in order to get a positive 5? Minus 1. That means this is going to be a minus 1. This is a minus 1. Okay, we then take this 9x squared, group that with the minus 1, and we do a single 3x plus 5. Remember, if I'm going to FOIL this, I would end up back there. Then I'm going to look down here, see if I have any special patterns. This is a special pattern, difference of squares. 3x plus 1, 3x minus 1, 3x plus 5. Final answer. Problem 2, hit pause, then come on back. Glad you're back. Out of this first group, I'm going to take 2x cubed that's going to leave me with x plus 7. Remember, I want this to be x plus 7 also. So what do I have to divide negative 112 by to get positive 7? It's negative 16. So it's going to be a negative 16 there, negative 16 in here. Then we take this 2x cubed, put it with the negative 16, x plus 7. And we want to see if anything can be factored any further. I can remove a 2. It's x cubed minus 8. Bring down the x plus 7. This jumps out at me as a difference of cubes. So our pattern is going to be a minus b, a squared plus ab plus b squared. Where in this case, a is equal to x, b is equal to 2. So we're going to come down here, we're going to go 2 and x minus 2, and the first term squared, x squared, plus first term times the second term, 2x, plus the second term squared, 4, and then bring down the x plus 7. Kind of complicated problem, you just have to look for the patterns. Problem 3. Okay, now this is going to be a little bit of a trickier problem. Okay, different presentation. These are still perfect squares. This is going to be 4x squared plus 9 and 4x squared minus 9. Okay, 4x squared times 4x squared is 16x to the 4th. Then we want to see if we can simplify any of these. This one here, special pattern, difference of squares. Can't do anything with the first one, so I'm going to bring that down. Second one becomes 2x plus 3 and 2x minus 3. Okay? Sometimes when I see these different powers, I cut them in half and I see if that would have helped me. And that would have, I would have done 4x plus 9, 4x minus 9, and then I just double these guys to get me. Since I cut it in half to see if I saw the pattern, and I just double it and gets me right back to here. Alright, number 4. Let's try number 4. Hit pause, see what you come up with. Alright, glad you're back. I can bring out a 2p squared. That gets p to the 6th plus 5p to the 3rd plus 6. Now I'm not used to dealing with p to the 6th and p to the 3rd, but I do notice that this is twice as big as that one there. So what would you have done if you had p to the 2nd plus 5p plus 6? Okay, where this is twice as big as this one here. Would you have been able to factor that? Sure. That's p plus 3 and p plus 2. All right, so this is going to kind of work out the same way. 2p squared. We're going to go p plus 3 and p plus 2. However, I divided this 6 by 3 to get a 2 and the 3 by 3 to get a 1, so I'm going to multiply by 3, so this becomes p to the 3rd and p to the 3rd over there. Then you're done because these are not any special patterns. Try 5 and 6, come back to us, see what you come up with. Alright, glad you're back. Number 5. I know I can take a 10 out of each of these. This leaves it x to the 4th minus 1. This here is a difference of squares. So that's 10 x squared plus 1, x squared minus 1. This one here can be factored further. So bring down the 10, bring down the x squared plus 1. X squared minus 1 is x plus 1 and x minus 1. Then you're done. Problem number 6. What can I take out of all these? I can take out 3x squared. Leaves me to x to the 10th plus 18x to the 5th plus 17. Now look, this 10 to the 10th power, the 5th power, twice as big, 3x squared. That's going to be x to the 5th plus 17 and x to the 5th plus 1. Okay. Hope you enjoyed this video, found it informative, and we'll see you on the next video.